Hello everyone. Today we're going to discuss some more methods of separation of substances. So the first method is, how do we separate the different gases from the atmosphere? Now we know that in our atmosphere there is different kinds of gases present. Now if we want to separate each of these gases from the atmosphere, how will we do that? So let us discuss the process. Now we know that air is a homogeneous mixture and can be separated into its components by fractional distillation. So I have learned in the previous class, or you can say in the last video, we have discussed about fractional distillation. So now we are going to discuss how, with the help of this fractional distillation, we can separate out the different kinds of gases from the atmosphere. So before that, let us see the flow diagram. So this flow diagram shows us how we separate the different components of air. So as you can see, now I'll explain one by one this whole flow diagram. So listen carefully. So first of all, you can see in the initial part there is a filter. So what does this filter do is that it absorbs the air. The purpose of this filter is it takes in the air. As you can see, the air is coming through this filter. So this filter, it does not allow the dust particles, as well as it absorbs the moisture present in the atmosphere. Now these are some unwanted substances which we don't need in our pure air. So the purpose of this filter is to block that dust particles, as well as it will absorb the moisture present in the atmosphere. Then after that, the pure air, it will pass through this pipe and then it will reach this compression chamber. Now why this is called the compression chamber? Because here the air that comes in, it is compressed. Now as we know, if the air is compressed, then what happens? The temperature also rises. So as you can see here, the temperature rises. So this air is under pressure and the volume will decrease. If you are compressing the air, the volume will definitely decrease and the temperature will rise. And as a result, the air that will pass through this pipe, it will be hot air. Now we have to cool down this hot air. So how to do that? So as you can see here, there is a pipe that is fitted here, a spiral pipe you can see. Now through this pipe, cold freezing water is passed. Now when through this pipe cold freezing water is passed and it comes out through this outlet, and when this hot air comes to this chamber, then when it comes in contact, when it comes in contact with this cold freezing pipe, the temperature of this hot compressed air, it cools down. And as you can see, when it cools down, again it passes through this pipe and this now becomes the cold compressed air. Earlier it was hot compressed air, now it is cold compressed air. Clear? Now it passes through this pipe and it reaches the separator. Now we know that in the compression process, the temperature rises because the volume of the gas decreases. Now here, as soon as it reaches the separator, here the volume increases. So there will be the expansion process, and in the expansion process, the temperature decreases. So already the temperature is cold, the air is cold compressed. Now as soon as it reaches that separator, this region, the temperature again drops, and it drops to a negative freezing temperature, say nearly -70 to -80 degree Celsius. As a result, what happens? It is that point at which carbon dioxide gas solidifies, and it solidifies into dry ice. So through this outlet, we can collect that solid carbon dioxide, or which we call as dry ice. Clear? Now the remaining gases which is present in that mixture, homogeneous mixture, the remaining gases, it will pass through this pipe and it will reach this expansion jet. Now in this expansion jet, in this region, the composition, or you can say the homogeneous mixture, it again expands. Now if again there is an expansion, then again there will be a drop in the temperature. Wherever there is an expansion process, there will be a drop in the temperature of the gas. So now it will be it will be expanded. As a result, the temperature will drop and it will then turn into a liquid state. So whatever gases are present, it will turn into a liquid state. And after turning it into a liquid state, it will become liquid air, which we call as liquid air, and then it will reach this fractional distillation column. After reaching this fractional distillation column, which is all the gases are in liquid state, now we have to heat it. As we know, in a fractional distillation process, we have to heat that what is called the homogeneous mixture. We have to heat it, and as soon as we heat it, we know that different gases have different boiling points. Now if you can see, here is a table given. The boiling point of oxygen is minus 183 degree Celsius, argon is minus 186, nitrogen is minus 196. So as you can see here, the boiling point of oxygen is larger than the boiling point of argon and nitrogen. Nitrogen is the least boiling point compared to oxygen and argon. So as a result, what happens, as soon as we heat that fractional distillation column, what will happen? The gases having a lower boiling point, it will start to evaporate. Okay, it will start to evaporate out through this outlet. So first of all, nitrogen will evaporate out, then argon will evaporate out, and then liquid oxygen will be only gas that will be remaining here. Clear? So as we know, in the fractional distillation process, not only evaporation, condensation process also occurs. So as all the gases condense out, or they condense down, you can say, so we can clearly collect nitrogen separately, we can collect argon gas separately, all will be in liquids form, and then we can separate out the liquid oxygen which is remaining here. So in that way, we can extract out the liquid oxygen from the atmosphere. From the atmospheric oxygen, we can extract out the liquid oxygen. And nowadays, you might have heard in the news that there is a scarcity of oxygen in the hospitals due to this COVID-19 situation. So in this process only, through the help of oxygen concentrators, which we say, we can collect out, or we can extract the atmospheric oxygen and store it in cylinders in the form of liquid oxygen. Not only oxygen, different kinds of gases also can be separated out and stored in the form of liquids in cylinders with the help of this process, or with the help of this this whole system. Through this system, we can separate out the different gases and store them out in form of liquids. So I hope you all have understood this whole flow diagram of how to separate the different components of air. Now moving on to our next topic, that is crystallization of copper sulfate. Now say for example, you are given a copper sulfate which is impure. Okay, so if you are given copper sulfate which is impure, so how will you convert it to pure copper sulfate? So for that, we have to follow a process that is called crystallization process. Through crystallization, we can purify the impure solids into pure form. Not only copper sulfate, there are different other substances. Through the process of crystallization, we can purify them from the impurities. So copper sulfate is just an example. So for that, we have to set up an experimental setup. So as you can see in the figure, there is the experimental setup for the crystallization process of copper sulfate. So one by one, we are going through the procedure now. First of all, what we have to do, we have to take a cup full of water, or you can even say a beaker full of water. And in that beaker, we have to add a few drops of dilute sulfuric acid. Okay, so in that beaker, actually, first of all, what we need to do, we need to add the impure copper sulfate crystals. Copper sulfate is a salt, inorganic salt. So we'll add the impure copper sulfate. Then we will pour a cup full of water. Okay, then to make the then we'll stir it with the help of a stirring glass rod. So after stirring it, to make the solution clear, it will be a homogeneous solution. So to make it clear, what we need to do, we need to add a few drops, 1 or 2 drops of dilute sulfuric acid. So the solution will become clear, crystal clear, and it will look like a light blue in color, like this color, as you can see, which I'm pointing with the help of my pointer. So like this color it will be. Then after that, we have to heat it. So we'll put it in a tripod stand and fix a wire gauge here, and then above it we have to put it in an you can say china dish or evaporating dish also we can say. In that dish we have to pour this solution, or this you can say the homogeneous mixture you can say, and then we have to heat it with the help of a Bunsen burner. After heating it, what happens, when it starts boiling, we will add some more copper sulfate powder, and we will again stir it with the help of the glass rod, and we will continue it unless and until no more copper sulfate powder can dissolve in it. Clear? So until and unless it can dissolve, we will keep on dissolving. Then what we will do, then we will cool down the solution. After cooling down, we will filter it out. We will filter the solution out. Then again we will keep it undisturbed and let it cool down properly. So after say nearly an hour or two, we will be able to see some crystal formation, and these are the crystals of copper sulfate, or we can say this is the pure copper sulfate, pure copper sulfate crystals. So the pure copper sulfate crystals will look like this. So in this way we can separate out the impure copper sulfate crystals and convert them into pure form. So this is one of the process through which we can separate out the impurities present in the solids. So there are other substances as well where we can use this crystallization process. Say for example, in the extracting of sugar from sugarcane, then we can say salt also. But salt we can do through evaporation as well. So let us see now the next slide, which is related to crystallization and evaporation. Now crystallization versus evaporation. Now which method is better, crystallization or evaporation? So let us see. Now crystallization technique is much better than simple evaporation technique. Now we know that what is evaporation. So much better than evaporation is crystallization in case of solids. So how it is better? So number one point is, some solids decompose, or some like sugar may get charred on heating to dryness. So what is charred? It means when we heat the sugar, if you try it by yourself, if you heat the sugar, what will happen? It will turn blackish, okay, in color due to too much of heat. So if we use the evaporation technique, then the sugar may either decompose or make a charred due to overheating. But in the crystallization process, there is no such problem of overheating. We let it cool down and then we get back the crystals. Next thing is that in this evaporation process, some impurities may be remaining dissolved in that solution even after filtration. As a result, what happens? On evaporation, they contaminate the solid. If there is some impurities, that means the solid substance is not pure. It is contaminated. But in the crystallization process, we have seen that we get back the pure solid form. There is no more impurities present in it. Clear? So in this way, crystallization process is better than the evaporation process. Now let us see some of the applications of crystallization. So where this crystallization process is used. Already we have seen now, just now we have seen how we can get back the pure solid form of any substance through crystallization. That is one application. So first application is purification of salt that we get from the seawater. Now we know that seawater we get through the process of evaporation. But as we know that evaporation, there is some impurities left behind. As a result, we have to, for purification, complete purification of that salt, we have to apply this crystallization process. Only then we can get the pure salt. We directly cannot take in the salt. Just after evaporation, we cannot just take that salt and eat it. It will be harmful for us because there is a lot of impurities left behind. Only after this crystallization process, we get the pure salt, which we can intake. Next, separation of crystals of alum. Now, alum, what is alum? Fitkari. Now you might have seen this fitkari. It looks like a, we can say like a small ice, but it is not that cold. It is used for antiseptic purpose also. You can see in the barber shop. Soon after they give a good shave, then they use it as a, just like it is just like a aftershave lotion, or you can say just like the Dettol which you use. So this alum is also such kind of a substance. Now alum, the separation of crystals of alum from impure samples. Now alum is used basically for the purification of the impurities dissolved in water. So in order to do that, first of all, the alum that we are using, it should be pure. So in order to make the pure alum crystals, we have to first of all separate out the impurities that is present in it. So just like the copper sulfate solution, here also, in order to get pure alum crystals, we can use this process of crystallization and then remove the impurities present in it. Thus we can say that crystallization method is used to purify the solids. Whatever impure solids we have, we can purify them through this method of crystallization. Now moving on to a next method, purification of drinking water. Now to purify the drinking water, there are a lot of processes through which we can separate out. Through which we can separate out. There are a lot of processes. So let us see those processes. Now we know that in cities, the drinking water is supplied from waterworks. So there is a water board which ensures that everyone gets safe drinking water, or you can say pure drinking water. So directly we cannot get pure drinking water right from the reservoir. So we have to purify it through various processes. Then only the water is suitable for drinking purpose or any other household purpose. Now, why we need to purify? Because there are a number of dissolved and suspended impurities that has to be removed before making it fit for drinking purpose. There are many impurities. It might be in the form of the particles dissolved in it, or it may be in the form of some microorganisms which are harmful for our body. So in order to remove it, we have to first of all purify it. Purify that drinking water or the water that we have got from the reservoir. So here is a flow diagram which is given below, as you can see here. So this is a typical flow diagram of a waterwork system, how this system works, and then we get the water through the taps that are fitted in our homes. So as you can see, now I'll explain one by one all this water purification system. So first of all, as you can see, the water is collected from the reservoir. So the reservoir can be the rivers, it can be the sea, it can be the ocean, whatever water bodies, or the lakes, or even the glaciers. It can be anything. So from a water body, which is a reservoir, we collect the water, and then this water is first of all sent to the sedimentation tank. Now what happens in the sedimentation tank? In the sedimentation tank, the suspended solids. Now there are many impurities which are suspended in the water. So first of all, in this sedimentation tank, the suspended solids are allowed to settle down through the process of sedimentation. They are allowed to settle down. Now after settling down, the topmost layer of the water is pure. That we extract out and send it to the next chamber, that is the loading tank. Now what happens in the loading tank? In the loading tank, with the help of that potash alum that we have discussed just now in the previous slide, this potash alum is put into it, and then this potash alum is used to remove the small particles like clay particles in a colloidal state, or particles like clay being negatively charged are neutralized by alum and are coagulated at the bottom of the tank. So what it does is that, in simple words, if I say, what it does is that when you put this alum into the water, it absorbs all the impurities that is present in that water. Clear? After absorbing all those impurities, the impurities can be in the form of clay particles which are in the colloidal state, or it can be any other dissolved impurities which even after sedimentation is left behind in the water. Those particles are absorbed by the, or you can say the suspended sediments, they are absorbed by this potash alum in the loading tank. Then after that, again the water is passed to the filtration tank. Now in the filtration tank, as you can see, there are different layers to separate out the impurities. Now it is a 3-layer system. As you can see, the first layer is a fine sand, then comes the gravel, and then comes the coarse gravel. Now this gravel and coarse gravel are nothing but these are small stones and pebbles which are put underneath the fine sand. And when the water passes through it, when the water passes above it, these impurities are absorbed by this fine sand, then gravel and the coarse gravel. They are absorbed. So in this filtration tank, what happens is that it is used to remove the dissolved solids by passing the water through the filtration tank, which, as I said, which possesses of 3 layers. Now the impurities are then absorbed by these 3 layers and are settled down at the bottom. And the top layer of the water is now pure, and it can pass through the chlorination tank. It can pass to the chlorination tank, and mainly in this chlorination tank, this bleaching powder is used to kill all the bacteria. In the chlorination tank, the bleaching powder is used in order to kill all the bacteria. And after the killing of all the bacteria, whatever water is now left behind, that water is fit for household use as well as for drinking purpose. And then it is what is called transferred to the homes with the help of these pipes. So you can see, with the help of this complete process, we can get the water which is fit for our purpose. So again, we can purify this water with the help of boiling process or with the help of some water filters. But through this process, normally the water is to a large extent purified. So in this way we can purify the water from the reservoir and make it fit for our own purpose. Clear? So this brings us to the end of the separation of substances present in the mixture. So I hope you all have understood it. Next day we are going to discuss some other topics. So you can go through your textbook again in this and read through this process for better understanding. So that's it then for today. Thank you and have a nice day.